So, on the previous video we saw how the anatomy of a point, we saw how we can make our grid. Now we will see how we are actually moving inside the grid without having to worry with the fancy stuff like AK and all that. We're only going to focus on moving from one point to the other and how we find what point we need to move to. Let's go to the scripts. We're going to create a few scripts. We're going to create a climb behavior. Let's go to the top. Now we have all our variables over here. Okay, if we are climbing, if we have initialized the climbing, if we are waiting to start climbing, you will see what's all this. Our animator, climb AK, yeah, forget everything that has to do with AK in this video. Our current manager, which basically the current grid we are, our target point where we want to go, our current point, a previous point, the neighbor, and the connection type. And we have climb state and the target state we're going to be. Okay, basically we are the climbing states we can be in should either be or when we are on point, where that means we can move to other points. When we are between points, it's when we are moving from one point to the other. So basically when he has his hands split. So the only ways we can move there is either go to the target point or go to the previous point. And if we are in transit, that means we are currently lerping to go either on the on point state or the between point state. We have a few curves over here which we're going to handle how we move, how we dismount, and how we mount on a climb system. And direct curve horizontal and vertical, it's basically just for jumping. Okay, because we do not want to do a lerp there, we want to handle a curve. We will see this in a bit. Interpolation variables, start position, target position, distance, t, initial, if we have initialized the transition, if we have reached, if the root has reached, yeah, the root of the character, and we have the AK land side, as I said, follow side. As I said, forget everything that has to do with the AK. Lock input, the input direction, our target position, our root offset. I have it as minus 0.86, and with the animations you have, you should also probably have it the same value. Okay, it basically is how much the hips are above the ground. So if I go, if you see over here, okay, you see the edge of the root. We turn this into pivot. It's basically the distance from the pivot to his hips. The speed we are moving when we are going linear with two-step transition, or the speed we are moving when we are jumping. And these aren't actually the values I'm using. The values I'm using are 0.3, 1.3 and 2. Okay, so this is 1.3. We have an animation curve, and this has to do with the IK. Enable root movement is also has to do with the IK. So yeah, forget about this. We're going to see them on a video that talks about all this. On start, before we starting basically, we get the component of the animator and the climb IK. That's the two stuff we need. And we also need to set the curve references, and because I do not want to have to drag and drop them all the time, I have a prefab that contains all my curves. Okay, and I load that from the resources folder. I instantiate it, I get the script I have over there, and I basically assigned my curves based on a function I have that returns a curve based on the type. So if I go into this script, you see I have a list of curve. I have a class curve, an enum curve type, horizontal, vertical, dismount or mount, list of that curves. Okay, and if I want, I pass the type and it's going to return me the list, the entry inside this list. And the prefab is climbing inside the resources folder. Keep in mind it has to be inside the resources folder, and the prefab is this. Okay, these are the curves I'm using. They do not have to be zeroed in since we override their positions and all that. So if I want to move horizontal and jump horizontal, I have a curve that is like this. Okay, depending if this is the starting position, I just jump there. For the vertical, from here to here. Okay, keep in mind this is also it's supposed to be mirrored, so you have to play a little bit with the curves and how they will look better. Dismount curve if you want to dismount and when you want to dismount, and the mount curve is basically just add the second point, doesn't matter, just add a little bit of curve, so it's the path is going to take, your player is going to take and grab on the climb system. Okay, make this into a prefab, assign them over here and assign the correct curve types, and make this into a prefab and drop it inside the resources folder. Let's go back into our climb behavior. Okay, we assign them all over here. We assign them into these variables. Let's close this. And then we have on fixed update. If we are climbing, we do all this. If we're not, if we have already initialized the climbing, we set the parent to null and we say init climbing equals false. And if you are pressing space, you are going to run a function called look for climb spot. Look for climb spot, it's now a pretty simple one, but yeah, you can tailor this for your own controller. Okay, it gets the transform of the camera, draws a ray forward of the camera. If it finds it does a raycast, the layer mask is going to ignore the object, the game objects layer. Is going to also ignore the layer of the ignore layer, the default layer Unity has. It's going to bit shift it. Yeah, this is the bit shift. It's going to make the opposite, not exactly the opposite. Okay, so we want to ignore these masks. The maximum distance is going to raycast for 20 points, and it does the raycast. Of course, yeah, 20 points is a lot. You can go with lower. And if it finds a hit and it finds a component manager on the parent, because we do not have the collider on the same okay, in the game object we have our collider, we do not have the script of manager, so we go get component in parent. It's going to return closest from our manager. We've seen this on the previous video. Okay, return closest, returns value. It goes and finds the closest one to our own transfer position, or yeah, the vector 3 from. So it will return the closest to our player. It's going to find the distance towards the point, and if that distance point is lower than 5, it will assign the current manager. It will assign the target point, which is the closest point. Target position will be closest point transfer position. Current point will also be the closest position, just because this is a special case. It's going to enable the climbing. It's going to lock input, so it's not going to take any more input. Target state will be on point, so when the lerping or moving to the curve ends, it's going to be on a climb stage on point. it's going to crossfade to climb, and it's going to go on the get component. It's going to go the state manager and disable the controller, which basically this what it does is goes and say it's a dummy model, make the rigid body kinematic, and make the collider a trigger, and it's going to enable wait to start climb. Okay, and this is how it looks for a climbing spot. So it's going to come over here, and the first time it's going to see that way to start climb is true, so it's going to come and say init climbing. To init climbing, it's going to update the arcade, as I said, forget them. It's going to say because the current connection is a direct and the target state is on point. Okay, connection type direct because we are going to use a curve to get there. And handle mount, we will see. Okay, initialize the lerp. Oh yeah, it's not a lerp exactly. It uses a curve to get on a position, but we use a t value, similar how we are going to use a lerp, but we add it on, we get the positions upon the curve instead of doing a lerp. So we need the transition, we reset the t, starting position will be our transfer position, a target position will be the target position which we set, which is the target point, plus the root offset. Okay, because we want to be placed a little bit lower than the actual hips. Okay, we need to have the offset. And basically, I mean, if the target position should be the hips, the root offset is where you want the pivot of your character go. Okay, the current curve will be the mount curve, since this is a special case. The current curve rotation for the current curve will be the same as the target point it has. We need to get all the points that we have on our curve. The first point will go towards our player. Okay, the order over here is important. And the last point on your curve, or your the target position will place the last point of your curve on the target position. How do we get the last point? We find dot length -1. Okay, so we started our lerp quote unquote. Okay, and we start adding to the tree, but only when we have enable root movement. In this case, we're not going to see what enable root movement is. Just ignore this for now. It's for the next video. Just add this. If the t is higher than 0.99, then set it to 1, just because the curve sometimes might get a little bit jerky if you get positions all on 1. So just do it at 0.99. Okay, way to start climb is false, lock input false, init transition. We basically reset our variables, and our climb state is the target state, so this means we're going to be on point at this time. And we'll get the target position by the t from the curve. Okay, this returns a position upon the curve, and we set that as our transfer position. And handle wait all, we'll see that on the next video. Handle rotation. Handle the rotation, gets the direction of the target point. If it's 0, then which is not going to be a 0, never. And it sets as our own transform forward. Target rotation, look rotation will be the target direction, and it does a lerp for your it rotates your character to look there. Handle rotation. Okay, and this is how you mount on your climb system, or your climb tree, if you want to call it like that, I guess. Okay, and we come over here, and we are now on handle climbing. Before we see handle climbing, let's see the initiate fall off, which is much more simpler. If we are on point and if you press the X key, okay, climbing falls, init transition falls, we close the AK, state manager, we enable the controller and we set on air on true because we probably are on air. Enable controller, okay, makes the dummy to be false, handle movement, the rigid body is no more kinematic, and the collider is also not a trigger. If you don't know what I'm using dummy for, is I have all my updates that have to do with the controller inside. I basically overwrite the update. I do not use update much on other scripts, and I just encapsulate the updates, or what was used to be updates, into ticks, and I call them one by one over here. We will see this in a bit if you haven't seen any other of my videos. Okay, and here's how you fall out of your climb position. So let's see the meat of it, which is handle climbing. Handle climbing, if we haven't yet locked our input, then we need to we start with the input direction. We want to start with 0. We get horizontal and vertical. Of course, you might want to tailor this and get the inputs for your own project. And we turn this into an input direction. Convert to input direction, gets the horizontal and vertical, and it's going to return us a vector 3. But look how this works. If horizontal is not equal 0, then that means we have movement. It's going to basically either hardcode it to -1 or 1. How it's going to select that is if horizontal is lower than 0, then it's going to place it directly on -1. So you do not have any fall through. Okay. And same for the vertical. And the Z, I actually have it over here, but I'm actually not even using it, so you can skip this part, because forward you can't go, you will go through the wall. However, later on we're going to see a few cases that you might want to go forward, and we're going to handle that differently. Okay, we set up the return value and we basically add the X, the horizontal we have the H on the X, and on the Y we add the vertical, and we return that. So we have our input direction, and if our input direction is not 0, that means we're moving. We have a switch state, and depending on the climb state we are, if we are on point or if we are between points. Notice I do not have in transition because that's a whole different case. We will either do each one of these things, which we will see in a bit if we are on point. Okay, as I write over here, the following lines hardcode the position of the player when you are on point. So if the point moves, the player will also move with it. We set up as our parent will be the current point, and if this has to do with the arcade. So what it does basically updates all target position on every frame instead of doing it only when you need it to. Okay, and if we have locked our input, then that means we are in transition, so that means we're actually moving and you cannot press anything else. Now let's see the between points, because on point is much bigger. Between points we pass the input direction. That means we are at, let's go on our wall. You see that, okay, the dismount worked, even if it didn't have a little bit of momentum. This state where it has the hands together and I can move into any position I want. Okay, this is the on point. This is the between point state. Let's leave it like that. So between points, from this position, I can only either go into this point or this point. We find the neighbor and we return the neighbor with the with the previous point. So what this does is you pass a target, and depending on it's going to look into its neighbor list, and it's going to return you that neighbor entry. Okay, if it's not null, that means there is actually a neighbor, and if the input direction is the same as that neighbor's direction, okay, then your target point will be the previous point. So if I move from here to here and I press to go back, I'm going to move back to this point. The target point will be this one. If I did the opposite, continue pressing to go to the right, then my target point will be this. Okay, I'm 1 point. I press one time to go to the right. If I press left, it's going to go back. If I keep pressing right, it's going to go right. Okay, else just assign the target point as a current point, and target position will be target point transfer position. Our climbing state will be in transition, since we are in transition. Our target state will be on point. When we finish the transition, will be on point. The previous point will be the current one we are right now. We're going to lock the input, and we're also saying to the animator move equals false, because the animator, how it works, if you are here, if the move is enabled, you are either on this state or on this state. Okay, so we need to disable the move. And this is the between points. What you do on between points. On point now, which is far more complex. Okay, on point, we start with neighbor null. We want to null our previous neighbor. We return the neighbor based on our input direction from our current point. So we're looking on our current point, and we're looking for another node that has the same input direction that we are asking. Or basically the direction we are asking is the same as our input direction. If we find that, okay, because we might be on an edge and we might not have any neighbors there, we assign the target point to be the one we have on our neighbor. Our previous point will be the current point. Climbing state will be in transition. And here's where we do a lot of stuff. Update connection transition by type. And we have our neighbor and our input direction. And we lock the input. Update connection transition by type comes over here. We pass the neighbor and our input direction. It gets the desired position. It starts with the desired position as 0. And our current connection will be the same connection we have on our neighbor. We need to find the direction between our point. So target point minus our current point. We normalize that. And depending on the type, so if our connection is a two-step or in between, we need to find the distance between our current point and target point. We need to find the desired position between them is our current point position plus the direction multiplied by half the distance. So what this does is gives you a position. Let's put it like this so that we can see. Okay, if you see over here, because if we didn't do that, we're going to be moving linearly. But what I want to do is, when on this step, I want to actually move the hips backwards instead of moving linearly. So it's basically doing an angle or a corner, if you want to call it that, between this. It's a little step that I think it works nice. Not a little step. This isn't actually the backwards. This is actually the middle point. Okay, the middle point of these 2 points is the position of this one multiplied by half the distance it has to go for the second point, divided by 2. So you get the middle point. Target state will be between points. When this transition is going to end, you are going to be on between points. You're not going to be anymore on between. Transit direction is for the animations. Basically, what it does is you pass a transition direction. Let's see where I have which is this: move horizontal, move vertical, jump up, jump down, jump left, jump right. Okay, it's basically just so we can work a little bit easier with the animations without having to worry having a lot of variables into our animator. So what it does, gets an input if you are jumping or not. Okay, the return value will be the default. It finds the angle, as we said, with the attenuation X and Y, and gets that into degrees. If you are not jumping, then it's not going to take care into account the angle, and it's only going to see if the Y is the absolute value of the Y. So basically, if you are moving vertically, it's either going to assign move vertical or move horizontal. Else, if you are jumping, then it's going to look on your angle with a little bit of offset, as we saw in the previous video, and it's either going to jump up, jump down, jump right, jump left. Okay, just pause the video and write this exactly as you see it. And if there is diagonal movement, which it shouldn't be, then it's either going to assign either jump down or jump up, and it's going to return that type. And from here it's going to play the animation transit direction. It's basically because I use to move between points on a climb system. I use either move or jump and the jump type. Okay, just to know on which one we move. So if I want to dismount and play the dismount animation, I use jump time equals to 20. Moving up will be jump time to 6, 5, and all that. It shouldn't be the problem if you download the starting project. Okay, this will already be set up, and that's why I'm not going a lot through the animator. If we want to move up, we're playing this animation. If we want to move on edge split, we're going to play this animation. I think this is also blend tree, okay, because it has mirrored from one side and the other based on the movement. And if we want to jump, okay, it all has transitions are based on the jump type integer, and that's why we need this function to translate all that into an integer, and it gets the enum, and depending on that it's going to assign the correct enums. It's going to set the integer of jump type, and if you're not jumping or not, it's going to update the correct variable on your animator. So this is the in between. If we are going direct, and if it's one step, the desired position will be the actual target point. Okay, we do not have in between points over here. The target state will be on point. Transition direction will be the same thing. We pass the direction and we play the animation, the correct animation. If we want to dismount, then desired position will be target point, transform position, set integer jump type to 20. We can hard code this since we know it's the dismount, it's a special case, and we set bool move to false, to true. And the target position will also be the desired position we have set in each one of those. So this is how we update the connections transition by type. So what it left to see now is the init transit for our input direction. In each transit, we pass the input, of course, which is going to be locked, so this will not change. So for any time we are on here, this will not change. We have a switch depending on what connection type we are. It's going to update the correct value. So if we have a two-step direction, it's going to go first and update the linear variables. Okay, in each transition, enable root movement, root reached, all this false, t is 0, start position will be our transfer position, target position will be the target position plus root offset, direction to point will be target position minus the start position, and we're going to normalize that. If we are on a two-step, okay, then the target state is going to depending on if we are between points. If we are, then it's going to add a little bit of back towards, so it's going to add a little bit position below our character, and that's going to make the target position. So it's basically, as I said, it's going this way. Instead of going linear from one point to the other, it's going to go something like this. Okay, if it's two-step. Then distance, you need to find the distance to help with the lerp, and you have the AK values we're going to see later. Then linear root movement, we get the speed linear multiplied by our time to delta time. Layer speed will be speed subdivided by distance, and we add to the t. If the t is higher than 1, set t to 1. We have reached the root, so the hips is actually reached the position they want to reach, and the current position will also be vector3 lerp unclamped, although you can have it clamped, it doesn't matter. And then we have start position, target position, and the t, and the transform position will of course be the current position we get by our lerp. Handle rotation, it's exactly handle rotation is exactly the same as we saw before. So these are for the AK. We have our linear and our update linear variables. The AK, we're going to see it on the next video because it just is a lot of stuff, and you'll be surprised that the AK actually is more work than the actual movement. So the wrap up, because we want to encapsulate to use it for both our cases. Okay, if it's a direct, we initialize it as false. So if the root has reached, and what we did over here, why we separate if the root has reached, is because you might want to have you might want to add the AK into the mix, and you might want to wait if the AK has also finished reaching on the correct position and all that. Okay, it might be not even needed. As you can see here, I did not take into account the AK, and I think it looks fine. So if root reached and we are not actually jumping, and the jump is false, and we are not waiting for a wrap up, then we're going to start the coroutine wrap up. We want to start the coroutine wrap up transition to be 0.05 and wait for wrap up to be true. What this is because you might have reached the root, and you might already be in the jump state, so the jumping animation hasn't ended yet, and we want this to run only once, to run this coroutine only once, otherwise you're going to have coroutines all the time. So we're waiting for this fraction of a second. Okay, then we assigned the climb state to be the target state. The climb state, if the climb state is on point, then the current point will be the target point, and we reset the values in each transition, lock input direction, and wait for wrap up to be false. And we do this because variables we might update before you have reached the actual point. Variables might start getting updated all the time, and you do not want that. It's going to look pretty ugly. Okay, and we're pretty much done with the in-between. No, not pretty much. We have done with the in-between. We only have to take into account the IK later. On direct, update direct variables. In transition, true. Okay, enable root movement false, root reach false, false, false. Reset the T. Root movement to T should also be 0. You will see what this is. Target position will be target position plus root offset. Start position, transfer position. Now we need to see if we are going vertically. To see that, we're going to see if there is any position on the Y of our input direction. If it's higher than 0.1, then that means we want to assign the direct curve vertical. So that means we are jumping up instead of jumping sideways. Okay, if we're not jumping up, that we are moving, we want to use the direct curve horizontal. The current curve, we rotate the current curve to have the same rotation as our current point. And if we are not vertical and we are not moving right, yeah, this is kind of, I could just as well do this anyway. Okay, if we are not moving right, then we change the Euler, we get the Euler angles for our current curve. We change the Y to be minus 180, and we assign them again, so it rotates with the correct, yeah, so it rotates the correct position, you know, because there is all the stuff with quaternions and all that. This is just a simpler way to do all this. If we are moving vertically and we are not moving up, then it's going to set the Euler angles. It's going to also change the X and the Y and assign the Euler angles once again. Okay, if we are moving on the right or going up, then the rotations the curves already have will work for us, so we do not have to reassign them. Okay, and then we need to set the points of the curve similar to what we saw before. The transfer position, the first point will be our starting position and the last point will be the target position, and then we handle the IK. Update direct variables, direct root movement. Okay, if you have enabled root movement, and what this does is basically I'm using this to add a little bit of delay before starting to jump, so you can hard code it and make it look better with the animation. And let's see an actual case. So notice when he is going to start moving, when he's going to jump on the right. Notice when he's going to start moving, he's actually moving on the curve, and he actually stacked, yeah, because we had all the, you know, the hotfix and all that, because we saved. Okay, notice when he's going to actually start playing the animation and when he's actually going to start moving on the curve. Okay, because this delay makes it feel more natural, like this. So we add a little bit of delay. So instead of adding to the curve all the time from where you are in transition, we just make a little bit of delay. We add the T when the enable root movement is true, and we multiply by the speed, of course. However, if we haven't yet added to the root movement, then we have a failsafe over here. So we start counting on the root movement T, and if it's higher than the maximum, if it's lower than the the maximum we have, is going to add to the route movement. So if it's by 0.3 seconds, if it's not enabled the route movement, it's going to hardcode it and enable the route movement. So this way you make sure your player will not stuck upon a point. Okay, it's just a failsafe. And if the t is higher than 95, remember what I said about the curves, just hardcode it to t, hardcode it to 1, and you say your route has actually touched. Handle weight all has to do with the arcade, so forget it for now. The target position will be the point we get on the curve, and the transfer position, of course, will be the target position. Handle rotation is still the same. And direct movement, direct handle, okay, we'll see it on the next video, and the wrap up will be this one. The same, but we say this time it's a direct move, which from what I can see over here, it doesn't even do anything else, but let's just keep it just in case we might need to add something later. Okay, direct, so we only have to see the dismount right now. Dismount variables, init transition, enable route movement, route rest, all this stuff, just somewhat the same. Here's where something changes. The current curve should now be, in any case, it's going to be the dismount curve. We get the points, we get the rotation, we set the first point to be the starting position, and the last point will be the target position, and we set the arcade T's we have over here. Dismount route movement, if enable route movement, we want to move a little bit slower this time, so we go even less speed. Okay, of course you can do this as a public float, but I think this works just fine. And if the t is higher than 1, then you have reached your route. Target position, we get the point from the curve, and we have that as a target position, and we assign that into our transform position. And the wrap up for the dismount is when we have reached our route, close the climbing, reset the initial transition, and enable the controller on the state manager. Okay, and we assign this over here. So basically we covered everything we have to cover to start having a climb system. All there is to do now is actually make the cosmetics like the IK and see how we can make a sample third person controller so that you can move around. So let's see all this in action. Notice what I'm doing over here, of course, and I'm going to hardcode this over here and take this, and this will probably how this will work. Yeah, okay, notice what happens and what indicators we have. Dismount curve, jump up curve. If I jump down, it's going to take, can't move directly. If I jump down, it's going to take the curve. Notice where the pivot actually is, okay, and not where the hips. Notice the pivot because it has the hips offset. Okay, it gets the vertical curve and rotates it by 180 degrees. Okay, we're going up, the same thing, but over here you get the middle point between this point and this point, and a little bit further back, and it looks like this. Moving up, okay, we're moving, jumping horizontally, it's like this. You can see how the curve rotates. Of course you can play with the route movement and assign it to what you want. Move forward, jump. This is linear transition, but you can see that because the points are closer together, it looks like this. Instead of jumping from one point to the other, it will move like that, and it will just make him stretch his hand. Let's go further up. Okay, jump. Notice that because we place the curve positions, it also updates automatically. Jump to the next one, and let's go somewhere where we have a dismount point, which is over here. And when I'm going up, you see that the way the dismount curve goes. But because we have the animation too, it looks like it's you do not see that the pivot actually goes through the wall. Now let's see the other stuff we have to do, because before we go into the climb again on the next video, I have on my animator, on the same game object that has the animator, I have a script called climb events. And what this script does, it gets, we assign the climb behavior. We need to find it, of course, so it will either go on get component in children, or if you have your animator as a child game object of the climb behavior, or the game object that has the climb behavior, then you need to assign, you need to change this to get component in parent. Enable root movement, or you do not need to assign this because you go on the root of your own transform and then searches for get component children, so it basically is going to find a climb behavior either way. So what it does, we have a public void that enables the root movement based on a delay. Okay, it starts a coroutine to enable basically makes the enable root movement to true based on we wait for seconds. So where we use this inside our animator, and on over here on each of these animations, because they can be differently. Now of course I didn't add differently. I have an animator state behavior with, I can set the timer. Okay, so let's jumping left, jumping right, jumping up, jumping down, and all that. Okay, moving up has nothing because we are moving linearly. To climb though, when we are initiating the climb, okay, timer will be 0.2, dismount will be 0.5. You see, because it takes a little bit longer to climb up, you just have a delay of 0.5. Let's see this one. Okay, it's a state machine behavior, so it's not mono behavior. We need to find the climb events and timer to be 0.2, and on state enter, if you do not have assigned the climb events, then it's going to find on the same transfer that it has the animator, it's going to get a component climb event. It's going to look for this script. If it's still null, then return. Okay, ignore. It's going to ignore this, and it's going to see and find. And when you are entering the state, if you find a climb events, it's going to enable the root movement based on the delay you have set over here. So this is basically it. The only thing left to do is handle see how we can handle the array and all the polishing and everything else we want to add on top of it. Okay, so we covered a lot, and the next part is actually going to be the most difficult part in my opinion. Okay, because making it look good like this, it's a lot of work. So I'll end the video now. You know what to do. Like, subscribe, Patreon, or grab a project or two from Gabroot, and everything goes in helping me to keep developing all this stuff, because as you can imagine, all this stuff take way too much time. So I'll see you next time.